But I'll just tell you, combustion reactions are going to have a driving force because if we look at, let's combust methane. If we combust methane, this is the RA, this is the OA. Going backwards here, this is the OA, this is the RA. And so we ask ourselves, what's a better oxidizer, oxygen or CO2? Oxygen. It's not on the chart, right? But you should know, oxygen is a much better oxidizer than CO2. In fact, CO2 is used in fire extinguishers. And so we're going from stronger to weaker. And then which is easier to burn, methane or water? Methane is much easier to burn, therefore it's a stronger reducer. Water is a weaker reducer. So there's one that's not on the chart, but it's pretty obvious. Okay, what else?
Which question was that?
That one, I just had a combustion question.
Purposely doing it to memorize disulfate, thiosulfate, and
Pyrosulfate?
No, thiosulfate.
Thiosulfate you don't have to memorize.
So it's just here.
Hmm?
It's just here for fun. Not for fun, but like.
Is it on your memorization list? Oh.
Oh no, it's on the thing.
No, like I said, these exams depend on the class and depend on what I teach. I decided on this particular class, you know, your exam is going to be not exactly the same as this.
Yeah. Ours.
And so it depends on what I teach that semester. This semester I didn't do thios this semester. Thiosulfate's really important. Thiosulfate's a really important reducing agent.
Yes.
But I was thinking, okay, we're going to cut down the memorization list. How often are you going to use thiosulfate in this class?
Whenever it's on the test, right?
Not that much. In fact, 0. So I eliminated thiosulfate from your list.
Okay.
Otherwise, there's thiosulfate. Somebody asked me in the afternoon class, what does thio mean? Do you know what thio means?
no.
Yeah, and so if you have sulfate and you lose one oxygen, you'll end up with 3 oxygens. And if you lose that oxygen and replace it with a sulfur, you'll end up with 2 sulfurs. So thio means just replace an oxygen with a. So somebody asked me about cyanate and thiocyanate. So yeah, cyanate's OCN minus, thiocyanate is SCN minus. But that's not on the list of 8s I gave you to memorize. Right?
How many reactions are found in nature?
7 or 8.
How many reactions?
Chemical reactions.
Innumerable.
So
So more than 4.
How many chemical reactions are found in nature is innumerable. How many types of chemical reactions
Okay,
are
there we
found
go.
in nature?
Yes.
Is that what you're asking?
Yes.
How many types of chemical reactions? From reading the book, can you tell me how many types of chemical reactions occur in nature? You think
7 or 8.
combustion, element plus element, combination, decomposition, single replacement, double replacement.
Like
And-
5.
And then later on, we're going to get to acid-base neutralization and some others. That's not a comprehensive list.
So a lot. So more than 4.
No. Where did you see that question?
It's number 4. Right there, right there, right there. To the right, right there.
More than that.
Yeah.
For 8.
Your book says there are only 4 types so far.
But isn't like
So
there's tons more like the redox and like acid base and hydrolysis and combustion, like all those ones?
Yeah, your book says there's more than 4 types. I say there's 3.
3 types total?
Yeah.
So then is it false?
should be fine.
This is false.
So the answer is 3?
Yeah.
Why is there only 3?
I thought we just listed more than 3.
Because the book said.
The book, it's the way the book categorizes it, classifies
So
it.
we should know that based on your categories, not just the book categories?
The book didn't give you the number.
Okay, so it's metathesis, acid base.
I didn't list all of them on the book. The book also had combustion, etc. So this would have been false nonetheless.
Okay.
But there's three.
Metathesis. Is it that one? Metathesis. Okay.
Uh-huh.
So metathesis, okay.
Figure number 29, is it just all about this number?
Yeah,
Yeah?
yeah.
Oh, okay.
Number 29. Number 29 is this.
There's one more.
Yeah. You start off with 18.02 grams of water, and then we convert it to moles. A mole of water weighs 18.02 grams. And therefore, we have 1 mole.
Oh,
And then we know that they're going to be 6.022 times 10 to the 23rd of whatever per mole. And so there's going to be an Avogadro's numbers worth of one mole.
Can we do the 31 parsley?
Can we do which one?
31 part B.
31 part C,
Part B.
part B. 31 part B. Did I give a part B?
Here, yeah, because you.
There are 2 31s and also 2 30s.
Oh, all right. Then I screwed it up. 31 part B.
Right. It's just double.
Yeah, we could do. Yeah, it's going to be double replacement. What's the formula for magnesium nitrate?
NGNO32,
Good. And sodium phosphate?
Na2PO4,
Na2?
2,
3.
3,
CO4.
Na2 or Na3?
3.
Na3. And what's going to form here?
magnesium,
NO3.
phosphate,
Okay, what's the formula for magnesium phosphate?
Mg3.
Na2PO,
PO2, PO4, 2.
Yeah, that's correct. And
also.
that's correct. Then we look for driving force. Is there a driving force for this? You're going to have more reactions because this was a, yeah, the different class, different type. Phosphates are,
Not solid.
yeah.
So
So it should be what?
Precipitate.
precipitate.
And
Action, solid.
solid? So this is the driving force. So let's go ahead and balance this.
3 sodiums on the right side. And then we have 8 plus 3 is 11. And we have 6 plus 4. Oh no.
Is that NO8 or NO3 on the left side?
NO3.
We need some more oxygen. You need to put a 2
Yeah.
on
You need to put there 2 Na3PO4s. That's 6. And then you need to put
So we have 6 here.
2 NO 2 on the right.
Oh, a 6 needs to be where that 3 is on the right.
Yeah.
So if we have, it should
Yeah,
be
6.
6. Now it's gonna be.
Yep,
Sorry,
that's
put
right.
here 2.
Yeah, then this would be right. 3 magnesium, 6 nitrates. 3 magnesium, 6 nitrates. 6 sodiums, 2 phosphates, 2 phosphates. All right, the next step is to write the ionic equation.
Yeah.
So what do we do for magnesium nitrate?
You split that apart.
Into what?
So 3
3 into positive plus 6 and all 3 negatives. And
plus
6
6
and
and
positive. And 2p of 3.
in English. But I'm still a certified teacher, so.
Do we split this one apart?
Then no, because I have no past chemistry, I'm still technically a certified teacher, so I'll just go teach. I would make no money.
How about sodium nitrate? Do we split that apart?
Yes. Because nitrates are solid.
Okay, and then what do we do?
We have some sodium nitrate.
And then we end up with this.
So, Professor, when we combine two acids, two strong acids, no reaction will happen.
Oh, no. What we do is, yes, you're right, no acid-base reaction will happen. So the question is, when we combine two acids, yes, you're correct, no acid-base reaction will happen. Let's do it. We'll combine two acids. If I combine two acids like this, there's no acid-base reaction that will happen because we got acid and acid.
So first,
No bases.
you do the reaction, you balance it, then you break it, you for and then you do the net equation, which is just removing that here, which is the sodium and the nitrate.
Yeah, and like I said in chapter 9 homework, they only write this as the answer. That's not what I want in your homework. I'm going to be looking for the driving force, the complete, the ion, and the net ion. Getting back to this, there is no acid-base reaction here.
No.
There's no metathesis reaction here, but there is a redox reaction.
Yes. There.
So it's when you're mixing two acids. Well, acids aren't just the only property you look at. You look at how many different. When I ask you how many types of chemical reactions there are, right? If there are innumerable, then you have to consider innumerable possibilities for this. Are there innumerable possibilities for this? No, there are 3 possibilities for this. 1, acid-base, but I go in this order. 1, metathesis, 2, acid-base, 3,
Redox.
are there an infinite number of more possibilities? Well, it depends on how you categorize it. If you categorize it like the book does, then you're looking at a huge number because you got to react it individually with chemicals, but we aren't going to categorize it like the book does. We're going to categorize it in a more general, broad sense. So after we look at redox, are there other possibilities? No. We hit the 3 basic types of chemical reaction. That's how I can answer. That's how you can answer what are the chemical properties of HCl. There are 2 ways you can answer what are the chemical properties of HCl. 1, you react it with every single substance in the universe and then see what happens. Or 2, you categorize it. And so in this one, there is a redox reaction. How can you figure out what the redox reaction is? They only gave you 2 redox reactions up to now, combustion and single replacement. So if I gave, this, how would you figure this out? You would use you'd use the chart method, right? And how do you do that? You inventory.
So this one would be strong. Strong oxidizer.
You look for the strongest, and when you do this,
The first one is up. Yeah.
then nitrate is, but nitrate requires H+. And then iodine,
We're using.
and then water. Then you pick the strongest, right?
Yeah.
And then you write out the reactions. When you write out the reactions, you have something like this. I just copied off the chart.
25. Yes.
Oh.
I just copied off the chart, like there. You see it?
Oh, I see.
And I use the chart to figure out which one is the strongest.
Is there gonna be a redox on this?
Of course. Because we had 3 types of reactions. I told you that there are going to be more reactions than on this practice because the practice is for a different class. The exams don't match exactly because the schedule was different. One of them was from the summer, and so it's a little bit different. We're going to have 3 types of reactions: metathesis, acid base, and redox. So this is why we spent, I don't know how much time have we spent on chemical reactions already. We've spent much more time on chemical reactions this semester than I did last semester. And so that's going to bias things. How? But for sure you can expect redox. So do you see this one we have to reverse right here, and so we reverse it. And then, do you see this is 3, this is 2, so we have to do the multiplication. Yes, so we multiply the top one by 2, the bottom one by 3, and then we just add them up, and so we get this. And that's the top reactants, and we do the bottom reactants. And then the top product, 2NO plus 4H2O. And then the bottom is going to be 3I2 plus 6 electrons. Now this is very important. The 6 electrons have to cancel. This is what I mean by that step, where the electrons can spell. And then we have to figure out the driving force. The driving force, though, we do by conjugate. So what was this again?
4.
The OA or the RA?
OA.
So if it's OA on this side, then the opposite side must be the,
RA.
okay, so this will be the RA. This would be the OA. And this was the,
RA.
and this will be the,
OA.
okay, so we do this, RA. This is the OA. And then we compare. And so we're going to compare the 2 OAs, let's say, for example. So if we compare nitrate and H plus with ID, which one's stronger? Nitrate and H plus or ID?
Nitrate.
And so this is,
Is it like one that's very
and then do you see, when you come up with a generalization, will 2 acids react? Did they? In this case, they did. In other cases, they won't. So for example, if I mixed HCl and acetic acid, then there's no reaction between these. These are compatible chemicals. And there's no problem with that. But in this case, there's going to be
So we didn't take apart the water because it is a weak.
the water's not the strongest. We got to do the strongest, and then water, we don't break it apart. We just leave it alone for water. This is the chart method. And so it depends on the case. You can't come up with these broad statements, these wide swath statements that acids won't react with each other. We got to look at the 3 types of reactions. Acids won't react with each other in an acid-base reaction, but that's not the only type. How many types of reactions? This is why we need to know the number of types of reactions. Otherwise, we'll never be able to predict, because in the back of our mind, if there are innumerable types of reactions, we'll never know, did we miss one? And so we need to know the types so that we cover all bases. All right, what other questions you guys have?
Could you number 30?
Number 30?
Yeah.
Which 30? First 30 or the second 30?
Well, actually, we did A. Didn't we do A
That was
yesterday?
31.
Oh, 31. Oh, this one?
Yeah, that one's confusing.
All right, since we're running out of time, I'll just do it. Boy, that's fine. So we have 0.05 milliliters of H2O. How many molecules of H2O16 H2 are there? All right, so if I have that many milliliters, how many, what I'm going to do is I'm going to go to grams. And so
Density,
what is the density of water?
1.0
1.0 grams.
per milliliter.
Okay, so now I know how many grams of water I have. If I know how many grams of water I have, then I can figure out how many moles of water I have. And so how many moles of water is that?
18.02 grams of H2O, 1 mole.
And then add that number.
Okay, now I have the moles, and what you see here is this is the mole percent. And so we're going to use the mole percent now. And so if we use the mole percent, then all that says is that they're going to be 0.0132 moles of H2
H2O16. H2.
per how many moles?
Oh, God.
Hmm?
The 100?
100 moles of what?
100.
H2O.
H2O. Okay, so now we have moles of H2O16H2. And the question is asking how many molecules. So then what we're going to do is we know for every mole
Yeah.
we have how many molecules. Not negative, times 10 to the positive 25 molecules. And so what does that come out to? 0.05 divided by 18.02 times 0.0132 divided by 100. Oh, shoot. 132 divided by 100 times 6.022 times 10 to the 23rd. .2 times 10 to the 17 molecule. This actually turns out to be a small fraction, but you know, it's one drop of water that has a huge number of these molecules in there.
Interesting.
I feel like there's good.
Other questions? Anybody else? All right. Well, again, we're going to run into a time crunch here, so I got to go quickly through 10 and 11. There.
Professor,
Yeah.
so tomorrow we'll do chapters 5 through 9 and lab supplement.
The lab supplement you don't have to turn in.
So just 5 through 9.
Just the homework. The homework's due.
Oh,
The lab, because the nomenclature, since I missed that lab, are you talking about exercise A?
yeah.
You don't have to turn in exercise A tomorrow.
Are any labs for tomorrow?
No, no lab. There's one lab that I asked for in your lab notebook, but the lab we did last week, you can turn in that later. So.
So nothing to do tomorrow, lab-wise?
Yeah, just turn in the homework. It'll make it easier. Did you finish the labs?